and refresh our memories and just what do we mean by vectors as such? कोई देना चाहेगा जवाब? Anybody who would like to answer? What
Ma'am,
vectors?
which have magnitude and direction too.
Or कुछ anything
Ma'am,
additional?
which follows the vector rules of addition, subtraction, and which have magnitude and direction.
Or कुछ?
Those functions whom we can associate that what direction the function has.
So basically what you are all trying to say is that anything that has both magnitude and direction attached to it, that is called as that is called as vector. यही बोल रहे हो ना?
Yes,
Hmm?
ma'am.
Okay. But I'm not saying that what you are saying is wrong, but what you are saying, the kind of definition that you are giving is a definition for a vector quantity. That definition is used by physicists. So basically, that is why we talk of two quantities there, scalars and vectors. So here, when to any quantity you attach a magnitude as well as a direction, then that is called as a vector quantity, right? But what I said was vectors, okay? So that is the definition that you have given is not mathematician's definition of vectors. In fact, for a mathematician, a vector is nothing but a directed line segment. That's it, nothing else. We don't want magnitude, we don't want direction to be written separately. We just say that a directed line segment. The moment we say segment, see, what does it mean? That means if you have one starting point here and an end point here, say OA, and say this is the direction to be followed. Sorry, this is your point A, and this is the direction to be followed. Then this whole in this direction is a line, okay, extended in both the directions. What are you doing? You are just picking up something, some portion, one portion of this whole line, and that is why it is a segment. And because it's a segment, that means it has a length attached to it. It is not infinite, it is finite. Okay. Because we're taking the direction also attached to it, that is why it becomes a vector. And we call this vector as the vector OA. Or if you call this length from O to A as A, then you call this as the vector A. You change direction, you get a different line. Okay. On this line, you pick up a line segment, say in this direction. You reverse the direction. Say I call this as B. Okay, maybe around this line I am measuring in this direction. So I get a new vector, but then again it is a line segment cut out of this new line. Is that okay? So now since we are working with mathematics major, if somebody asks you what is a vector, then the ideal definition is that a directed line segment. That's it. Nothing else attached to it. The way you, because I mean, not you, I mean, we till now, the way you have studied vectors, you have studied it as quantities. You have talked of velocity, you have talked of force. So things like that. You've talked of acceleration. So they are specific physical quantities to which a direction has been assigned. So you are assigning a direction to speed and you are calling it a velocity. So the difference between the way vectors is defined by physicists, and the way a vector is defined by mathematicians. Okay. Now, then once, of course, once I have identified a vector, then we have defined various rules for a vector. I mean, say you do know how to add any two vectors, you know how to subtract any two vectors, and then when it comes to the multiplication, say if A is one vector and B is another vector, then I can talk of A dot B and I can also talk of A cross B. So we know the geometrical significance also. We know that A dot B always ends in a scalar quantity and A cross B ends up in a vector quantity. So if A and B are any two vectors, then their cross product is another vector. So directions, which is orthogonal to the plane containing both A and B, right? So direction is assigned to A cross B as well. So we have learned all this. Okay. So basically, what you are familiar with is what we call as algebra of vectors, in the sense that when you perform algebraic operations on vectors, what all are you going to get? Okay. So I'm not going into the details of that because that is not what we have to do it. I'm assuming that you have done it in your schools. So I'm just building more on that. So that's why I'm saying we would be more interested in studying vectors as functions, because now what we want to do the calculus of vectors. Basically, we want to now study not the algebraic properties, but we want to study how analytically the vector can be used and studied further. Okay, so that's why what we are interested in studying is vector valued functions. Okay, so now see, if I call them as vector valued functions, that means we're talking about functions in the background, and functions we know is what? We have studied too much on functions now, right? But then what kind of functions are we interested in studying? We are interested in studying those functions whose values are vectors. That's why we are calling them as vector valued functions. So basically, what are we doing now? We have, see, if you go back to your course that we started with, we have studied Cartesian functions, we have studied parametric functions also. Okay, and we have studied polar functions as well. Now, in polar functions, not exactly a direction, but yes, we assign the orientation of the curves. Whether you are making your angles, you are measuring your angles in the anti-clockwise direction or in the clockwise direction. So accordingly, we have definitions. Okay, but if you remember parametric, right? So what did we do? We studied x as some function of t and y as some function of t, and then we study how the function is going to behave when you give some limits to, say, varying from t1 to t2. Okay, so this is something we have studied, right? Now, what I mean to say here is, supposing here also we assign, some direction to these parametric curves. Okay, that means I assign, say, the direction to x, I assign as, say, unit vector I in the positive direction of x-axis. So basically, this is that portion which is defined by this, but with a direction in the unit direction, the positive direction of x-axis. Similarly, to this, I assign a direction j. I add them up. I get another vector. Let me call it as r. Okay. Now see, supposing, say, let's talk of this. I define x as 2 cos t and y as 2 sin t. The curve, just in the parametric form, no direction as yet. What is going to be the curve? Hmm? क्या कर्व बनेगा ये? X is 2 cos t, y is 2 sin t. What curve do we get?
Then circle.
It's a क्या बनेगा? फिर से बोलो एक बारी तो.
Then
Ma'am, circle.
It's a circle. Guess a circle.
Circle with a center 0, 0 and radius 2.
Radius how much?
Yes.
Radius
Radius
1 by
2.
2.
Ma'am, radius 1 by 4.
1 by 2.
Radius 1 by 2.
1 by 2.
1 by 2, yes, ma'am.
No, ma'am, 2 only.
Yes, ma'am.
Ma'am, only 2.
This will be
2.
2. Okay, na? Why? Because you are when you add x square and y square, what is the equation you're getting? X square plus y square means 4 cos square t plus 4 sine square t, which means 4. So that means the equation that you have got is x square plus y square equal to 4, which means it's a circle with center 0, 0 and radius 2. A1. Now,
Yes, ma'am.
see, we are still in the xy plane. I mean, when third axis पे नहीं आई हूँ, right? So basically, what does it mean? That means I have a circle like this. Center 0. This point is 2, 0. This point is minus 2, 0, 0 and 0 minus 2. We're going to get a circle like this, right? But my circle can be in this direction and my circle can be in the opposite direction also. So it could be anti-clockwise or clockwise. It depends upon the orientation of the circle, right? But now supposing I say, okay, let us assign directions to these components only. Instead of assigning, see, assign direction to it. When we assign limits on t, how does it vary? Whether t varies from 0 to pi or t varies from 2 pi to 0 or whatever be the directions. Okay, so that is assigning an orientation to a curve, right? But now what we are doing is when we say we are assigning a direction, that means we are fixing the movement of every component. Because see, this is a parametric curve. So this is the x component, this is the y component. Now if I say, I define my other curve R as say xi plus yj. That means what? It will be 2 cos ti plus 2 sin tj. Okay. Now, when I say, okay, at t equal to 0, what will be the position of the what will be the position of the point? If I have any point on this boundary at t equal to 0, what will be my r?
2i.
2i. 2i basically means what? Where are you?
X-axis.
X-axis.
X-axis, right? In the positive direction of x-axis. How many units? 2 units. So you are at this point, right? Similarly, at t equal to pi by 4, you will get to know which direction are we moving in. So basically, this is giving a direction to every component of a function. So such functions are called as vector value functions. So basically what we are now, if I am assigning I and j, definitely we know that a third axis also exists. So I could have xi plus yj plus zk. This is a vector. Okay, where to every component I have assigned a direction. Or kaun si direction? Unit directions along the 3 coordinate axes of x, y's and z's. Positive directions. Okay. So basically what we are trying to say here is that if I have a vector function, if I have a function such that every component of that function can be assigned a direction along the unit directions of the 3 coordinates, then such a function is called as a vector valued function because if you try to find the value of this function for any value of the parameter t, you will end with a vector function, vector quantity. Okay, so that depends upon हमारा function किस तरह से defined है. Okay, so like for example, को आगे extend कर देते हैं. So supposing I write it as, now instead of 2 cos t and sin t, I write it as 2 sin t and plus 2 cos t j plus say 3tk. This is supposing this is this is how I define my function. Okay. Then what does it represent? So if you just see this part is going to see this is your x, y's and z's are there. Okay. This is the 3 x's. So this is your x, this is your y, and this is your z. So basically these two terms are going to define how your curve is going to behave in the xy plane, so which is going to be a circle of center 0, 0 and radius 2. And this defines what? The movement along the z-axis, right? So it's like when you are gradually, it will be something like, you know, you start moving from your this thing. Now see what happens. इसी पे ही देख लो. What happens at t equal to 0? Where are you? Where is your ft? मैंने deliberately change कर दिया है दोनों x और y को interchange कर दिया है.
2j cap. 2j, ma'am. 2j cap.
Right? At t equal to 0, your ft is 2j. So that means where are you? Not on the x now. You are on the y-axis. यही हो गया ना इसका?
Yes.
So basically, when you now sketch the circle, so it's अभी मैं ऐसे बना रही हूँ, but it's going to be something like ये इस तरह से बनेगा, but at the same time, this is also changing. So that means it's going to be gradually something like this. You know, you will go up. ये circles तो यही रहेंगे as you move t. No, center all of them will change, but the radius will remain the same, 2 units each, because you are moving up. So it's like you are, it's basically like a circular helix, which you are going to get, because it's like you on the x plane, you have a circle. So you just have to, I mean, it's just like, you know, one thin rod that you have. So you just have to place it one above the other, and you get what is nothing but a spring. So basically this direction, this quantity is going to give you the direction of the spring, whether it's up or below. Had it been say minus 80k, no, the other two remaining the same. So that it's again a circle, but now you have to move in the negative direction of the z-axis. Okay, so this is how the curves can be traced, or you can find the values of the functions for different values of. If you want, you can try the homework. Try finding the values for different values of t. T को 0 put करो, t को pi by 2 put करो, t को pi put करो, and so on and so forth. Do it at least till 2 pi. So you will know how this helix is actually moving. Okay, because then you will get up t equal to ये k and be 0 because you were only at 2j. But when this is now, when you substitute t equal to pi by 2 here, treat it as a real number. So you know the value of pi here, and then you will get a point on the z-axis, and so on and so forth. Okay, so this is how we can talk of vector functions, where to every component of that function we are attaching a direction. Okay, now because that means whatever we have studied for functions so far. So if I have this function, this is a standard vector valued function which I'll be writing always. f1ti is f2tj plus f3tk. Okay. Now this amounts to saying, if I just let this I for the time being, this f1t is just like another function, any other function of t, right? Similarly, this is any other function of t. This is also any other function of t. But then we have combined them by assigning functions to each of these functions. Okay, so that is why we are calling them as a vector valued functions. But since they are functions in themselves, That means whatever we have studied for functions in our calculus so far, everything can be applied here. That means I can talk of limits of vector valued functions. I can talk of continuity vector valued functions. I can talk of differentiation for vector valued functions, and I can talk of integration also for the vector valued functions. The only difference, the only care that we have, like for example, supposing I have to find the limit of ft when say t approaches t naught, some specific value. Okay, so basically this amounts to saying that each of the component of this function is to be studied separately, but in the combined together. In other words, what we mean by this is that I'll be talking of limit t approaching t naught of fti plus limit t approaching t naught of f2tj plus limit t approaching t naught of f3tk. So this is how I'm going to find the limits for this valued function f. And a limit will exist when each of these three limits exist. In case one of them fails to exist, it will not exist. Okay, so that is the only thing. Similarly, every component of this function has to be continuous at t equal to that specific point, say t1 or t0. Then only we'll say that the vector valued function ft is continuous at t equal to t0. Okay. Similarly, if I have to find the derivatives here, so derivatives would mean, say, supposing that means if I have to find df by dt, so this will be nothing but the derivative of the first component I plus derivative of this component plus derivative of this third component k. Okay, so that means each of the components is to be differentiated separately and then of course put together, because that is how it is going to change. So basically, what do we mean? We are now studying the changes, rate of change of this vector valued function with respect to what? The independent variable t. And how is this total change being studied? The way each of these components are changing with respect to t in their respective directions. Okay, so that is how, see, this is how, now you can go relate it to your physics. Say, supposing r is your radius vector or the displacement function, right? Then what is dr by dt? If r is the displacement function, how do you define dr by dt? क्या कहते हैं?
मैम
This, ma'am.
Velocity. It's velocity. इसको velocity
Yes.
बोलते हैं, right?
Yes, ma'am.
And velocity is a vector quantity, mind you. And what is, if I denote it by v, it's a vector quantity, then what is the magnitude of v called? The magnitude of velocity. क्या बोलते हैं उसको?
Now speed.
Speed. Magnitude of velocity is the speed. Okay. This is how the calculus basically of vector valued functions can be studied. Okay. The thing is that expressed in terms of a vector function or something like that. Like for example, say I have z equal 4 x square minus
मैम
y.
सॉरी बट बिल्कुल भी आवाज नहीं आ रही.
Yes, ma'am.
मैम कल भी और आज भी.
अब मैंने जब शुरू क्लास करी थी तब तो आ रही थी.
मैम अभी नेटवर्क का कोई इशू हुआ, आई डोंट नो मैम, बट आपकी आवाज बहुत ज्यादा ब्रेक कर रही है.
मैम लो है बहुत. ब्रेक तो नहीं कर रही बट लो है.
मैम पीछे वाला टॉपिक जो अभी जस्ट पीछे वाले पेज से पढ़ाया था वो एक बार रिपीट कर दीजिए.
Okay,
वहीं से ब्रेक हो रही थी आपकी.
okay, I'll do that. I will do that. ये वाला वापस आ जाए ना. यहाँ पे डेरिवेटिव से
यस मैम.
ठीक है. Like as I was saying, we can talk of the limits, continuity, differentiation, and integrals of vector valued functions. In which, I mean, how do we study that? We perform, because each component of that vector valued function is a function in itself. So since if we have to find the limits, we'll find the limit at each component. If we have to find the derivatives, we'll find the derivatives of each component. And to find the integrals, we'll find the integrals of each component separately, right? And say when we say supposing I have to check whether my given vector valued function is differentiable or not. So for that to be differentiable, every component independently should be differentiable. Then only I say that my vector valued function is differentiable at that particular point t or not. Okay, like as I was saying, so supposing r is your displacement vector, then dr by dt is nothing but your velocity. And since velocity is a vector quantity, that means the magnitude of the velocity will be nothing but the speed. And so supposing you are given the displacement, so supposing you are given a particle, and say suppose, and you are given a particle moves in such a manner that the displacement function is defined by 2ti plus e to the power tj sine tk. I mean, this is just one function which I'm saying. So this is how, and where t is what? Time. Okay. Means how the displacement of any particle or any point P is going to be defined at any time t. And I'm asked to find the velocity of this. Velocity, say t equal to 0. Okay, so what are we going to do? That means your velocity, we know, is nothing but d by dt. The rate of change of displacement with respect to time is velocity. Okay, so when you say dr by dt, that means you have to differentiate this whole function with respect to time now. So differentiate whole function means differentiating the x component, differentiating the y component, and differentiating the z component separately. So this will end up like I plus e to the power tj plus cos tk. This is how I'm going to differentiate each component separately. Do we have to find when t is 0? So we say velocity when t is 0 will be what? I just put t equal to 0 everywhere. And what do you get? You get 2y plus j plus k. Now what is it? 2y plus j plus k is a point. कहाँ पे? XZ plane में. 2, 1, 1. ये हो गया ना इसका?
Yes,
So
ma'am.
basically you have the velocity at equal to 0 there. Okay, so when we are saying differentiability, we are saying continuity, it is all component wise. Okay, now the other thing that I was saying was, supposing I am given a Cartesian function, can I express it as a vector valued function? Yes. How? Say supposing you are talking of some curve which is say something like this, and I mean it's an intersection of this and this. Okay, so it's like you have this curve and this curve. In fact, this is a solid because that is defined in terms of x and y's here. And another curve that you have, these two intersect with each other and the resultant is something, right? Now we want to write the resultant in the vector, in the form of a vector equation, in the form of a vector function. Okay, so to do that, the best thing is put them down. I mean, express all of them in terms of just one variable t, and so that each component, I mean, try to define each component separately, x, alag, y, and z, but all of them in terms of t. Okay, like in this case, I say y is already defined in terms of x, and in this case, z is defined in terms of both x and y, right? So if y gets defined in terms of x, it can be replaced in this, right? So what is only to define your x in a different manner. So what I do is I'll say, okay, if I put x equal to t, then how much is your y? T square. Okay, because now I want to have only one variable under study. And how much will be your z? Under the root 4 minus x square. X square means t square. Minus y4 means minus t to the power 4. यही आ जाएगा.
Yes, ma'am.
Now, that means if I now express my f in the vector form, it's going to be what? Xi plus yj plus zk, right? So what would that be? Last about right. So this will be like ti plus t square j plus under the root 4 minus t square minus t to the power 4k, isn't it? So it's like you have moved. It's the same function, this, they are not different. But what have you done? It's only the expression which is different. In the sense that you have expressed a Cartesian function in terms of a vector valued function. You've assigned a direction to it. So you can always move, like in the case of movement from vector value to Cartesian, kya kara? We are just studying the three components separately. Okay. Similarly, here also we have just tried to, just bring them down in terms of one variable and then move. Okay. This is how we can always, switch over from Cartesian to vector and vector to Cartesian. Not just this, whatever operations you have performed on vectors can be performed on vector valued functions also. In the sense that if I have f and g as two vector valued, you can add them, you can subtract them, right? You can talk f dot g, you can talk of f cross also. So everything that you have studied in terms of vectors, quantities can be carried over to the functions also. Okay. Then once we are okay with this, I think then we can talk of limits, as I told you how to find limits of क्रॉस प्रोडक्ट भी कैसे निकालते हैं आता ही है वो तो सबको, है ना? And then you can
Yes,
talk
ma'am.
of functions being continuous. I mean, the vector function will be continuous, as I was saying, continuous at say t equal to t naught if each component of f is continuous at t equal to t naught. Okay, this is how we continue to as well. Okay, I think for today I will end up here only because iske aage agar if I start it's going to take long. So for today I'll end up here only. I'm not in a hurry.